Today we're going to be talking about derivatives and their use in Calculus 1. So, starting off this lesson, we're going to see what even is a derivative. So a derivative is the rate of change at a specific spot in a function at a point. So it gives us the slope of the tangent line to the curve of a function at a specific point. So what does this mean? So let's draw an example graph to a simple function like x squared. So derivative at a certain point, let's call this point A, so point B, will be the slope at point A and point B. So at A would be that, and B would be here. So the derivative is a way to characterize this. Instead of just guessing the slope, let's say maybe it's 3, then maybe let's say B, that slope is -2. We're just guessing here. But the derivative gives us a way to actually find that specific point and express that as an equation, and then at a certain x value, we can actually find the slope itself. So generally, derivatives are going to be expressed as d over dx. And if there's a function here, that's the function we're taking a derivative to. So this says we're taking the derivative of x, f to respect to x. These can be any values. You can do d of y, dx, which is another common one. You can do d of x, y. It doesn't really matter what you're doing, but as long as you remember that the bottoms which you're taking respect your derivative to. So whenever you take the derivative, you're going to get another quotation that another way of writing a derivative, which is common, is f prime of x. And this is not a 1, the little mark right there. That's a prime. And that's going to express how many derivatives you're taking. So this would be the first derivative. But you can have fn of x, where n is the number of derivatives. So you can have f1 prime, f2 prime, f3 prime, all the way to f a million prime. So moving on, how do we even take a derivative? The first rule that we're going to want to focus is for polynomials specifically. That's anything to x to a certain power. This x can either be, for the n exponent, can either be an integer, fraction, or a decimal. All these will work in this rule. So how do we do this? Let's do an example. So we have x to the third. So in this example, our n value is going to equal 3. This guy, this one. And so when we're taking this, we want to do first n minus 1. So n minus 1, in this situation, 3 minus 1, 2. And we can pull that n and put it next to our quotient. So we're going to put 3 here, x, and then our n minus 1, so 3 minus 1. The derivative answer is 3x squared. And what does it actually mean, though? Putting this into an example back into our graph. So let's draw our graph. And let's actually draw x squared. So it looks a little like this. So if I say, give me the derivative at point x equals 1, x equals 1. So we can plug in this x value into our now known derivative. So I'll say x prime of 1. Remember, that prime means first derivative equals 3, 1 squared. So it's just going to equal 3 again. So that means at point 1, so let's say this is 1 here, that this slope equals 3. So that's simply what it is. The derivative is going to give you the answer to your slope at a certain point, aka the rate of change. And it's actually very helpful in lots of engineering, physics, and biology concepts, especially, for example, like in engineering, you have a displacement graph, velocity graph, and acceleration. You can derive all of those graphs through just taking derivatives of the displacement graph. Cool. So let's do some more examples of the power rule. Cool. D over dx of x to the fourth. So again, let's just find our terms first. N equals 4 in this situation. N minus 1, 4 minus 1. So we're going to put that n value, and then x, 4 minus 1, 4x to the third. Just so you guys can remember as well, I will write the power rule, so you guys don't have to look back at your notes. Cool. So that's going to be our first answer. Let's do number 2. Let's do d over dx of x to the 8th. It doesn't really matter what this n value is. As long as the n value is an integer, decimal, or fraction, we should be okay. So n equals 8, a minus 1, 7, simple addition, or simple subtraction. So n value, x, a minus 1, 8x to the 7th. Cool. Now let's put this a little more application. D over dx. So find the derivative of x to the 7th at x equals 3. So n equals 7. 7 minus 1, 6. So we can now put our x value here. 7x 1, 7x 6. Now let's plug in our x value, the problem assigned. 7 third to the 6th. Put this into the calculator. 5,003. So at the point of x equals 3, so at x equals 3, the slope of x 7th is 5103. Cool. So now we're obviously gonna have more complicated equations. But how are we gonna solve these? So another rule that we're gonna want to use is constant multiple rule. So this defines, let's say, derivative of c, which we're gonna say is a coefficient, some kind of constant. 1, 2, 3, whatever. So this is going to equal that we can actually take the constant out. We can take the derivative separately of the function. So these two are exactly the same. So let's do an example. 4x squared. Now in this situation, we still need to use the power rule. The power rule is always going to apply when you're doing power rule, or always doing polynomials. So we still have our n equals 2. And to simplify this, we can pull this 4 out. That look a little better. D over dx of x squared. So now our n still equals 2. 2 minus 1, 1. So we have 4, 2, x, 2 minus 1. 4, 2x first equals 8x. And commonly, some students, they won't actually decide to take out this constant. You can do it if you want. You don't have to do it. One thing I will always advise is don't forget about it. I have lots of common mistake with students is they leave that number out, and then their number is not correct because it won't be scaled correctly. So another example on here. Let's do a fraction this time. So n value equals 2. 2 minus 1, 1. So 2. And write out the whole thing out. The new one, taking the fraction out. So now I have 2x, 2 minus 1. So I have 1/3, 2x to the first. So that's pretty easy. You don't need to write this 1 here. I'm just doing it so don't forget about anything. Or a little more simpler. Cool. So another more concept I want to talk about is taking a derivative of a constant or a coefficient. So we have c in here. This is always going to equal 0. So the reason why this is, if we look at a graph, let's say our graph is going to be a representation of y equals 3. 3. So the rate of change at any point of this graph, our m value of the slope, is always going to be 0. So if we're taking a derivative at this point, this point, this point, or this point, they're all 0. 0, 0, and 0. So it only makes sense that the derivative of any spot is going to be 0. So the derivative of any number, it can be 1, derivative of 7 million. These are both going to equal 0. And this will be very useful when it comes to we have polynomials, like we'll see in the next example. We have a derivative of, let's use a different variable this time. 3y fourth plus 2y squared plus 5. So just remember that this only says we're taking respect to y. The trick you can do with derivatives is when you have a polynomial like this, and they have separate terms, you can split these all up. You don't need to take the derivative all the same. So you can put these separately, and as if they're completely separate problems. However, stay consistent with what you're doing, and do not forget about your signs. You can either take the sign in or take it out. Ultimately, this equals -1. So you can put it here, or you can take it out, whatever you want to do. I recommend taking out the negative, makes it a little easier on yourself. So let's apply the rule of taking out the constants for all of these. So 3 d over dy, y to the fourth minus 2 d over dy, y to the second, plus, we can take this one out as well, y of 1. So as you see this, you can just cancel this out. It's going to be 0 anyways. So you have in this situation, n equals 4, 1 in the middle, n equals 2. So 3, 4y third minus 2, 2y plus 0. Just to show where we're getting these terms from. 3 is that one, 4 is here. We have 4 minus 1, where I'm getting this guy from. This one here. This one here. And technically the 1 on top of that y, but it doesn't really matter. And then this constant value. Let's do another one. dx 2x to the fifth plus 5x squared plus 3x squared plus 4. Similar, so we have polynomial, 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 and constant. So we're just going to ignore that constant. We can split this all up into separate problems. And for this one, I'm not going to take out the constant just to show that it's the exact same thing. Cool. So the first one, n equals 5, n equals 2 in the second one, and n equals 2. Here, n equals 0. So coming out to this, 2, 5x to the fourth plus 5, oops, yes, 5 2x plus 3 2x plus 0. Fourth plus 10x, 6x plus 0. That's going to be our final answer. A quick recap on the steps that you always want to take when you're solving these derivatives. So first, identify what your n value is. This will make it pretty easy. 2. Remove any constants. This will help kind of simplify your equation, make it a little easier. 3. Split polynomials if you can. And 4. I'll definitely say write neatly. If you can stay more organized in these questions, it'll make it a lot easier on you. Cool. Let's do another example. This one's going to be a little different. 1 over x. This is still a polynomial. So we can still use the power rule. This looks a little different. But let's get out of fraction. We want to avoid fractions when it comes to taking derivatives. So this equals to 1 over negative x, or 1 to the x to the negative first power. These are the same exact things. So in this value, what we're first going to do, find what our n is. So n equals negative 1. Remove any constants. We don't have any constants. And we don't need to split any or do any derivative separately because we only have one term. Okay, so move down here. d over dx of x minus 1. So we're going to move the n term bottom. We're going to do negative 1 minus 1. X to the negative second. Some teachers, they'll want you to more simplify. Either way, you should know how to do both of them. It's not that hard, just taking it to the bottom. It's another weird one. 1/3. So don't panic. Just because it's a fraction doesn't mean it's not unsolvable. So our n equals 1/3. You can do x 1/3. Oops. 1/3 minus 1. So this is the same thing as that. Move that n value over here. It's going to equal 1/3 x to the negative 2/3. And let's more simplify this further. 3x to the third is going to be your final answer. One thing you don't want to do, this is very crucial, don't convert your fractions into decimals when you're taking derivatives. It makes it very complicated. A number like 1/3, it equals 0.3333. It goes on to infinity. So it's more accurate if we leave it as 1/3 versus making it to 0.3333 to infinity, even though it's still correct. However, it's more accurate. Just leave it as 1/3 and it's easier. All right, last example. So how are we going to solve this one? It's not exactly a normal polynomial that we've seen before. There is one rule that we can do to solve this, which is called quotient rule. However, we're going to cover that in a different video. Starting off with solving this, just a reminder of what our exponential rules are. So you have x to the x, let's not use the same variables. Say x to the fourth over x to the second. The same thing as saying x to the fourth minus 2. When we have fractions that are above each other, if we have decimals and a fraction, we're going to subtract them. And then when we have exponentials multiplied together, we're going to add them. So in this one, we can just divide our x squared by all these terms because there's only one x term. So let's do that first without the derivative stuff. Squared, fourth, x squared, plus 5x third, x squared, plus 2 over x squared. Simplify, x to the third, plus 6x squared, plus 5x, plus 2x squared. And now we're going to run on step 3, like I said before. Now we're going to split it up to different derivatives. Split, not split. d over dx of x cubed plus d over dx of 6x squared plus d over dx of 5 plus d over dx of 2 over x squared. Sweet. So we're gonna, in this one we have n value equals 2, right on the top is 10. Or sorry, n equals 3. This one is n equals 2. Equals 1. And n equals negative 2. Remember, we can move this to the top if we want, but we'll leave it on the bottom. 3x squared plus 6 2x plus, so this is going to be 5x to the 1 minus 0. Oops. Be just 5 on this one. For this one, I'll show this one on the top. Move this guy up here. So x minus 2, n equals negative 2. Negative 2 minus 1, negative 3. Just be careful with your negative sides with adding. Sometimes, I still get our mom as well. 2, negative 2, x to the negative 3. Our final answer is going to be 3x squared plus 12x plus 5. It's going to be a minus 4x to the negative 3. So this is going to be a small recap now we're going to do on what we learned today. So first we had power rule. So we stated for any polynomial, we can take a derivative as such. X to the n, this is going to equal n, x, n minus 1. And for a second rule we did, constants, slope rule. And for this one, we said d over dx of some constant value of the constant equals taking that constant and putting it on the outside, and not even knowing it was there until the end when you add it again. But then we also said that the derivative of a constant will always equal 0. And so this is going to be comprehensive what we did today. Again, I want to show a small example of how our derivatives actually apply to real life situations. So earlier in the video, I explained, or I gave a small example about displacement. So if you have x equals distance, you have time. And let's say, let's think of a car. You have a Mercedes car, and it travels 20 seconds, and it goes 10 meters. This is how far it's going. Now, this car, it will be going at a constant velocity. So, for us able to know the velocity of what this car is going for, we need to know the slope of this line. So what we can do, we can take the derivative. I'm just going to draw the first quadrant of this graph. And the derivative of displacement or distance is actually going to be velocity. We'll talk about more about why that is in a different video. And since this is going at a constant speed on the graph on the left, we can say that the velocity is constant at whatever speed that it's going. That's what this is, v. And then what's depicting how fast something is going is if it's accelerating or not. So the derivative of velocity is acceleration. So say acceleration, time, and then since the velocity is not changing at all, the derivative at this point, n equals 0. So it's just going to be a line at 0. It's a little bolder so you guys can see this, but this is at 0 though. So that's going to conclude our video. In upcoming videos, we're going to be covering chain rule, quotient rule, as well as product rule. Be sure to hit the like button and subscribe, and comment if I made any mistakes or would like to see any other lessons. Thank you so much.